Okay, so let's begin this problem. So as we talked about a second ago, we've got a 8,500 pound rubbish bin. You can see the center of gravity there. And I've got contact points at A and B, different coefficient friction. You're supposed to neglect the height of the supports at A. And the one thing we need to notice is just as the garbage bin contacts the truck bed, the normal force will be perpendicular to the truck bed. So I'm going to draw the free body diagram of this thing. So I'm going to start by looking at the garbage bin. The first thing is I'm going to have the mass of the truck acting through the center of gravity. So that's the 8,500 pounds. I didn't draw this to scale. Then at A, I'm going to have a normal force. Now, which way is the garbage bin going to move, right or left? To the right. So that means my friction force is going to be to the left. Now at B, the whole thing rotates. So at first, I'm going to have my tension force in the cable. I'm going to have this normal force at B. And I'm going to have a friction force at B. And this is 30 degrees. So let's see, I'll go ahead and make this 30 degrees so I can get my components there. And this would also be 30 degrees. So I have all my geometry. Everybody see that? So how many unknowns do I have? I got 1, 2, 3, 4, 5. Seems like I got too many unknowns. So I'm going to have to make some assumptions. The assumptions are is we're just getting ready to move. The other part is you'll notice that the friction at B is going to be a little bit less than the friction at A. So probably it's going to start to break at B first. Okay?
Could you sum the moments at B to get?
That's a great place to start. Let's sum moments at B, because this is very confusing here. There's lots of forces going on. In fact, at B, there's 3 unknowns. So let's do that. Let's sum moments at B. Make sure in equilibrium. So what do we have? We've got the 8,500 pound force, and it has a moment arm. I didn't draw that in there. That's 12 feet. 10 feet, so that would be 12 feet. The friction force at A is going to pass through B, so I just have the normal force. And that normal force at A would create negative moment with a moment arm of 22 feet. So I should be able to solve for the normal force at A. So that's 8,500 times 12. I got 4,636 pounds. Does that seem reasonable? So there's one of them that I know. let's sum forces in, I don't know, at this point I don't see a clear path. We may have to just sum our forces and see what we have. Let's sum forces in the x direction. So you may not always see a clear solution, but you can always write your equations of equilibrium and see what's going on. So starting off here, looking in the x direction, I have the friction force at A moving to the left. I have the x component of the friction force at B also moving to the left. So that would be the friction force at B times the cosine of 30. I have the normal force at B also moving to the left. And that will be sine 30. And then I have finally the tension force, the x component of the tension force. Well, that seems horrible. One equation, 4 unknowns. Not a good place. All right, let's hold on to that one. Let's go to the y component. Let's see what we get. We got the normal force acting up. We have the x component of the normal force over here. That would be normal at B cosine 30. Then the friction force at B times the sine of 30. Wow. And then plus the vertical component of the tension force. And finally a number. Wow, not very exciting equations to look at.
Doesn't have N of B have to be equal to whatever 8,500 minus N of A is?
Now say that again.
Doesn't N of B, like the normal force of B, have to be equal to the weight of the tractor minus the trailer minus the normal force of A?
Well, you've also got the tension of the cable. It doesn't look very good, but you'll notice I haven't made any assumptions yet, so I'm going to have to go back and add something to this. I'm going to have to assume that the both friction forces have reached their max because we've got impending motion. So as I start to move at B, right, I have to also start to move at A. So it looks bad now. I have two equations in 1, 2, 3, 4 unknowns. But I can say the friction force at A is 0.3 times the normal force at A, another equation. And I can say the friction force at B is 0.02 times the normal force at B. So believe it or not, there's one equation, 2 equations, 3 equations, 4 equations. Now, 4 equations, 4 unknowns, okay, it's not that bad. It will take some time to do, and I may not do it here. I may just give you this problem for homework and let you finish it. But you'll notice that if I plug these guys back into here, for example, let's go along, we have some numbers. So I've got normal A, normal B, force at B. If I plug that back in, I'm going to get an equation in normal A, normal B, and T. Go back up here. Let's see, normal A, normal B, T. If you work on this enough, you ought to be able to come up with some substitution. And eventually, all we want is the tension force. So you want to solve for T. It would take some time to do. So I wanted to show you this problem because it kind of jumping out of the box, it's a little complicated. But the important thing for me is that you write your equations of equilibrium and then what assumptions you make. Now, we do have the normal at A. That's the one thing we do have. So it looks like we have, so if I have normal at A, then I have the force at A. So that's something I do know. So what I don't have is B, normal at B, T. So if you start plugging your values back in and take your time, you should be able to solve it. I'm afraid to do it here because I think I'll mess up. But I think you guys can manage it. Let's just talk about it for a second. Since I know the normal at A, I know the force at A. So if I look at equation 1, this is a number. Okay? Then if I plug this in here, I now have normal B, T. So I get a relationship between normal B and T. Okay? If you go to the second equation, I know normal A. There's normal B again. Force at B, normal B, T. So I have two. I could reduce these to two equations in the normal at B and T, and then solve those resulting two equations. You should be able to solve for T. It would take some time. Now what I may do is after you finish the homework, after you have a chance to do it, I'll publish the solution. But it would just be manipulating these three things, or these four equations. So even though it's a complex problem and the solution is challenging, the statics is once you draw your free body diagram, the statics just follows along. You may not like the result when you get it. It may be challenging to solve it. But for me, the problem is really done. You've made your assumptions on the free body diagram. You've assumed impending motion at both points, and you've been able to write four equations in 4 unknowns.